Hey guys, welcome back everyone and good evening all of you. So guys, a quick question to all of you with the use of IP. Okay, what is IP? Internet Protocol, layer 3 addressing used to identify the location of device and identify the user. That's the use of IP, right? Okay. And at the same time with the IP is what? IP is a connectionless protocol, first of all, right? So it's not a connection like a full. So in IP communications, what happened for the IP communications? You're not going to make a first connection, right? You're oriented like a TCP. They are doing right first. They are forming a three-way handshake, right? And then after that, they are doing the data exchange. In the IP case, it's not like that. It's a connectionless protocol. We are not going to require any prior connection, right? No need to require any prior connection, right? So IP is a connectionless protocol. If I'm going to use IP with ICMP, again what happened, this guy is not going to provide the any kind of connection oriented service. Still this guy is going to use the connection list. The reason was, right, the reason is very simple to introduce the ICMP protocol, right? The reason is very simple to introduce the ICMP protocol to just provide the error detection or error, sorry, what do we call this guy, error reporting. Because IP protocol does not have a mechanism of this person. The first IP came in the picture in the 1980 when the first RFC was introduced in the 1981, the IP, right? And after that, they introduced the ICMP protocol to just make a error reporting. Because in the IP, what happened? We can provide the communication, but the thing is that they are not reporting the error if this person is available or not. Likewise, what happened? Every person, right? This guy A and this is the B, right? A know the location is the HSR layout Bangalore, right? And B, you know the location is the Delhi Pashchim Bihar. 1918 Nizam, the RFC 1980, you're saying that, see, IP has a multiple RFC. If you just go through the Google, they have almost 6 to 7 RFC. So one of the 1980 RFC is just going to tell you like it's a private and public IP addressing. Okay. So they have a multiple RFC and depend on the RFC, they have a different mechanism as well. So 1918 RFC is just going to say the private and public IP addressing. So the location A person is belong to the HSR layout and B person is belong to the Delhi location. So this is what? This is the identification, right? The user is sitting in this location, right? Same thing in the networking world. What happened, guys? Same thing in the networking world. What happened? Every PC or every devices has a IP. Every PC and every devices has a IP, and that is used going to provide the identify the location of the devices. And based on that, we can provide the communications. If you don't know the location of the device, you cannot send your data traffic or you cannot send the any traffic, not the data, not the management traffic, not the control traffic, if you don't know the address of the device. And the address of the device is known as a IP. The address of the device is known as a IP. Now try to understand. For example, this is the PC, right? On this PC, right, the PCA and this MAC address of this person will be A, right? On this PC, you can give the IP address in two ways. The first, you can use the static that always going to represent the manual process, right? And second, you can go for the dynamic. Now, the thing is that till this point, whatever the things we have discussed, right? All we have discussed with the static configuration. all we have discussed in the static configuration. In the static configuration, what happened? You need to go on every devices and need to define the static IP. Okay, this PC has a 101 IP address, this PC has a 102 IP address, this PC has 2.1, this PC has 3.1, whatever the IP address you have to define. At the same time, with the IP addressing, you need to define the subnet mask as well as. The reason of to define the subnet mask so that they will identify what subnet we are using. So that they will identify what subnet we are using. If you are not going to put the subnet mask information, they will incomplete the command and they will not accept the command, right? The PC and the router will never accept the command. Without subnet mask, the PC and the router cannot identify what subnet we are going to use, right? So IP is very, very important to send the traffic to the any person, right? You can give the IP in a static way or the dynamic way. Now the thing is that, take example, if you have a 10,000 user, and that's not a big deal for the one company, right? In the MNC company, 10,000 is not a big deal. It's not possible to give the static IP addressing for this person, because if you're going to give the static IP address for this person, what happened? You will require the lots of the time, right? And again, cost comes in the picture, right? Because you need to require the more network engineer over there. Because for one network engineer, it's not possible, right? You need, at least you have to go for the 10 and 20 network engineers, and every person has to give the IP addressing manually. And second thing, whatever the IP address that you are going to give the on the user, right? You have to maintain the diary. Okay, for this PC, I have allocated this IP address. For this PC, I have allocated this IP address. For this PC, I have allocated this IP address, right? To just avoid the, I need to maintain the diary, right? If I'm going to give the static IP address to the user, I need to maintain the diary. Okay, I have a, give the IP address 101 to this user, 102 for this user, 103 for this user, and everything I have to give the manually. Second, third thing is what? If I'm going to do the manually, right? If I'm going to do the manually, how many things we need to give to the PC? One, we have to give the IP addressing, subnet mask. These two information must need to give to provide the LAN communications. Try to understand, we need to give the IP addressing and subnet mask information for the LAN communication. But if I would like to go for the WAN communication, what happened? We need to give the IP addressing, we need to give the subnet mask information, we need to give the default gateway, and we need to give the, for which person? And everything I have to define what? Manual. Try to understand, if I'm going to define the manual, in the manual, what happened? 100% you're going to do the mistake. Error will be there, right? Maybe take example on some PC, right? Maybe on some PC, what happened? You forget to configure, right? On some PC, you forget to configure. Aja. On some PC, you forget to configure default gateway. On some PC, what happened? You forget to configure DNS server information. So on some PC, if you forget to configure the default gateway, can this PC ping to the internet? Never. It cannot go to the internet because they don't have a default gateway information. Because here everything I'm doing the manually, and manually what happened? Error will be 100% there. So to avoid all these problems, right? To avoid all this problem, we have introduced the concept of dynamic allocation. Every single thing like IP addressing, subnet mask information, default gateway, DNS information, everything I can assign dynamically instead of the doing a static, because a static has a lots of issue, right? The biggest issue with the static, the time consuming. This is the biggest issue, right? Third issue is that we have an error. We need to maintain the diary, right? And the cost always. So to avoid all this problem, we have introduced the concept of what? Dynamic. Dynamic allocation of IP address is known as a DHCP. DHCP stand for the first thing. Dynamic is what? Automatically, right? I'm not going to define the manually, right? This is the automatic. Host means what? I'm going to give this IP address to the particular host. It can be a PC, it can be a server, it can be a printer, it can be a router as well as. And I'm going to configure this IP configuration via the protocol, right? Clear? Now, this DHCP, right? For the DHCP configurations, what happens? You need to create the, and in this pool, you need to put some IP. So whenever the user will require the IP address, right? Whenever the user devices will require the IP address, they will take the IP address from the pool, right? Whenever the user will require the IP address, on a single DS, on a single Cisco router, right? On a single router on a Cisco, right? You can create a multiple pool. You will have a multiple pool on a router, and each pool has a own subnet. Subnet in the sense of what? For example, this is the pool one, right? Pool number two, pool number three, right? And this all this pool are present on a single router. To identify this pool, we need to put the identification. We can say the CCNA. This pool name is CCNA, or we can say the LAN one. This is the LAN two, and this is the LAN three. And this LAN has some information. For example, I allocate this person 1.0.0/8. This will be 2.0.0/8, and this will be 3.0.0/8. So from this pool, user will get the IP addressing. And all this pool are present on a single router virtually. And this pool has to define by the network admin. You need to configure all the DHCP configuration, right, on this router by the network admin, whatever the requirement you have. For example, what I'm going to do on this router, I say that IP, the first command, IP means what? The first command in the IP is going to tell you, okay, this command is just going to tell you, hey, okay, I'm doing the configuration for which person? IPv4, right? If I'm just going to include the IPv6, it means that I'm going to create the configuration for the IPv6. So the IP and second command is what? I need to configure the DHCP. And then after that, I need to create the pool and need to define the pool name. That should be LAN1. Once I put this configuration, what happened? This configuration I'm going to do on the global configuration mode. Once I put this configuration, what happened? Automatically, you will move in the DHCP box. And under this DHCP box, what happened? We need to define the pool IP address. Which network I'm going to use? I'm going to put the subnet 192.168.1.0/24. Or either you can follow like this one network. So either you can follow this command, or either you can go for the this one. Some iOS versions support the both of them. Some iOS versions support both of them. Some iOS versions support the only this guy, not this guy, this guy. And we have a space in between. Clear? That's it, right? This is the enough configuration, guys. This is the enough configuration to provide the IP addressing to the user. Enough configuration. And based on this configuration, right? Based on this configuration, a PC1 can communicate with the PC number 2. But if you want to provide, this is the LAN communication configuration, right? But if you don't provide the WAN configuration, what will happen? We need to do like this: IPDSC pool LAN 1. Then I said the network will be 192.0/24 and default gateway. And if you don't define the DNS server information, you can define the DNS A101. Or if you don't define the, if you have a multiple DNS server, you can define the multiple. So this will be a primary, and this will be a secondary. Okay, yeah. On the router, the command is default router. This is enough configuration for the WAN and LAN. Let me show you the first overview how the DHCPs will like how you can allocate the dynamic addressing. Then we'll go for the packet level detail, right? I'll show you the first basic information in the packet tracer. Then I'll come to the packet capture and whatever the DHCP like a DORA process is happening, right? So right now, if you just open this PC, they don't have any IP configuration. If you see, they don't have any IP configuration. This guy is a by default static. You can put the DHCP as well as, right? Let's go on the router. Enable config terminal. Host name will be R1. Interface 0/0. IP address will be what? /24. No shutdown. Then the basic IP I did all there. So this interface IP address is what? 192.168.1.100/24. Right? Next thing what? IP DHCP pool. Define the pool name. Network, I'm going to assign 191.168.1.0. Then if I'm going to put the network, take example. They'll prompt the error. So this command is supported by the some iOS. If you go for the GNS, it will support over there, right? In the packet tracer, it's not supporting. So on the some iOS, on the updated or whatever the updated iOS we have, all this iOS will support this command, right? No, there's no whatever the subnets you have, you can define it. We can like limit that range as well as we'll see that later on. So now if you see, I'm done. So if you see after putting the IP DHCP pool CCNA, what happened? I move in the DHCP configuration box and we did all the configuration. I have assigned the pool IP addressing, and that's it. Now if you see, go through DHCP and I'll get the IP address. I'll get the IP address on this guy as well as I'll get the IP address on this guy as well as and this guy as well as. I haven't defined the default gateway, right? It means that without default gateway, can I get the IP address? Of course, we can get the IP address, but we can only provide the LAN communication. So if I'm going to ping, take example, I can write. So from here, this is the 101 IP addressing, this is the 102, and this is the 103, and this is the 104. But I don't have a default gateway, right? If you not provide the default gateway information, you just need to go in the router, IP address pull CCNA, and say the default router will be. Now, go on the PC, IP configuration, put the static DHCP, refresh this guy, and see, I got the default gateway. Same thing, if you not define the DNS server information, you can define it. So right now there's no DNS server, right? I can go on the router. Sorry. CCNA DNS server will be 8.8.8, right? Done. Go on the PC, static, refresh it. All this thing has done by the dynamic Reddit. I'm not going to define it on a PC and just define the manual IP. Everything is done by dynamically. Clear? Now let's see how this thing is going to be work in the background. Let's take example. What I'm going to do, I'm just going to open GNS3. So again, depend on the requirement. If you need a default gateway, define the default router configuration. If you don't need a default gateway, don't define it. If you just provide the WAN communication, LAN communication, no need to define the default router information, right? Hmm? Yeah, of course. That's again, if you want to go for the WAN side, you have to define the deals. I'm just taking a two routers right now. Okay. And I'm going to make this guy one is a client. Okay. This guy's I'm going to make it this guy's a client. And I'm going to make this person is a server. All done. On a R2, this router, right? This is the server, right? So I'll just define the host name DHCP server. Then interface 0/0, IP address will be done. No shutdown. Debug IP DHCP server as the events class linkage. And right now I don't want any kind of packet right now. IP DHCP 2. Define the name CCNA. Hit enter. Network /24. What happened? If you see this output, I've created the one pool. That pool name is what? And in this pool, what I'm going to allocate over there? 1.1, 2, with CCNA. So this amount of IP address that I'm going to put in this 101 to 255 is reserved for the broadcast, and 1.0 will become my network ID. So user will get any of this IP address from this book. Same way, in same, like I can create another pool, IP DHCP pool, CCNP, and I say the network will be what? 2.0. What happened? Which pool? So I can create a multiple pool on the router side, right? Now, try to understand what happened if I'm going to remove the pool. I'm going to delete this pool, the CCNP, and all this subnet IP address will be removed, right? The complete subnet. Now try to, I just need to go on the router side. On this router, what happened? If you see interface 0/0 IP address, if I'm going to define like this IP address is known as the manual configuration, right? This IP address is configured as a manual, right? That's done by the network engineer. What I can do right now, I just say the no IP addressing, and as the IP address DHCP. I want to take a IP address on this particular interface from the DHCP. Got the IP. What is the matter is happening? Do so IP interface brief. From math manual, I'm going to use, and I got the IP addressing. Do so IP interface brief. Sorry, do so IP uh, root. Clear. Now let's have a look. I'll say the shutdown. I'm going to release my own IP addressing. Let's capture this link. No shutdown. Once I'm going to put the no shutdown, what client will do in this case? Client is now going to look up IP address. So what they will do, they are just now going to perform the discover. Client will look up for the IP address. Now this guy is going to perform the discovery, right? So in this discovery, what happened? They will put the source MAC information will be what? My own information, C201, that's the MAC address of this particular interface. The user MAC address. Destination MAC will be what? Because I don't know where is the DHCP service present, right? I don't know where is the DHCP service present. So I put the source MAC will be what? Destination MAC. Type field will be what? Ether type. What is the size of this guy? Then after that, what happens? Source IP will be what? I don't know where should I forward because I don't have IP addressing, right? Because I'm looking for this person. I don't have a IP addressing. Distance IP will be what? I'm going to make a broadcast, right? Protocol number 17 UDP, right? Source port number. Distance port number. And then after that, we have a discover DHCP data. The 68 reserved by client and 67 so 17 is the UDP protocol number. Like ICMP has one, TCP has और कुछ बताओ इसके अलावा. Right? Try to understand. This packet will be sent by the PC number one. Don't worry, guys. I'll give you all the possible scenario, right? I'm just giving the overview right now. We'll go through the switch in between. We'll go through the VLAN in between, everything, right? When the PC one will send this packet, what server will do? Server will accept this packet, right? Now, try to understand. If you go on the server side, right, on the router number two, right? This is the router number two, actually, the server side. On the server side, port number is open. 67, right? UDP server. If this guy is open on the server, right, on a server side, then what happened? It will give the reply. Listen to me very carefully. UDP 60 port 67 port number is open by default, right? If this port number is open on the server side, then this message that is generated by the client will send this message to the server. Server will first see, hey, do we have a 67 is enabled on this my server? Yes. If this guy is enabled, then what happened? It will give the reply. Otherwise, what? It won't. And by default, this will be enabled. You can you can disable this port number as well as take example what I'm going to do right now. As a no service DHCP. Guys, just give me 2 minutes, right? I'm just coming back. अब टैलेंट को आता हूँ टैलेंट Yeah. Telnet. Where's the 23? Oh, you just asking this person? Yes. So guys, by default, this command 67 will be enabled, right? By default. If you just have a look on the client side as well as, so tell me one thing, if I'm going to enable, right? If you see by default, this command is enabled. This is the hidden command, not this one. This is hidden command. And what this command is going to do? If I'm going to disable it, what happen? Will my DSP work? No. I'll show you this thing. Don't worry about that. If I'm going to disable this thing, it will not work. So right now, what happened? And let them enable over there. I'm not going to disable this person, right? And now let's go now router number one and say that interface do swipe interface brief. I don't have IP address interface 0/0 no IP no shutdown and IP address DHCP and have a look. Got the IP right? One or two on the client side. Now have a look. This packet client is generating to the R2. Open the first packet. Discover source MAC address, user MAC address, destination is what? Broadcast type is what? Source MAC CT01, destination broadcast type is IP. Internet protocol is what? Source IP? I don't know. Destination IP, source port number, destination port number, DHCP. Now let's do one thing. अब पढ़ते हैं इसके बारे में क्या क्या दिया हुआ है. Then dynamic host configuration protocol. The first packet we have a Discord packet, and the message type is what? Boot request. It can be reply as well as. For the request, the opcode value will be 1. For the reply, opcode value will be. zero. Huh? Why? तुक्का मारा था ना somewhere. Okay. Now the question is that what is boot? Request. Why I'm saying the request message, because right now the PC is requesting for the IP addressing, right? That's why I'm putting the request. Question is what is boot? इसके लिए चलो हिस्ट्री में थोड़ा सा 9080 देखते हैं बूट क्या होता है. Now, ओके अब बूट ट्री से पहले पढ़ लो आरआरपी क्या होता है. दिख रहा है? इस विजुअल विजुअल है. फॉन्ट बड़ा कर दो क्या? नॉट विजुअल. यार we are trying to learn DHCP. We are trying to learn the DSP. But again, what happened? The boot comes in the picture. And when I'm trying to learn the boot, RARP comes in the picture. So in 1984, on the time, right, behind before the 1984, what happened? If the PC wants to get a IP addressing, if the PC want to get IP addressing from the dynamically, not the statically, what happened? We are on the time we are using the reverse R protocol. What this guy is going to do, RARP. Take example, whatever the PC we have, right? All this PC are positioned in my same LAN, right? And this PC wants to get IP addressing. What happened? They will request to the RARP server. So what happened? This PC right now, they don't have IP addressing, right? They don't have IP addressing. They are going to request to the RARP server to get the IP addressing. So what happened? This guy is going to make a request and server will give the IP address to this guy. This guy is going to make a request, server will give the IP address to this guy. This guy is going to make a request, server will give the IP address to this guy. This guy is going to make a request, server will give the IP address to this guy before 1984. Now, if RARP was there, then why they introduced the boot P? And then why they introduced the DHCP? Try to understand RARP has some problem, right? The problem was very simple. This RARP is only going to give the information over the IP addressing. That's it. They don't. They will not give the IP addressing the default gateway, not the DNS server information, nothing. Second problem, the RARP is what? It's layer 2. Layer 2 in the sense of what? For example, if you have a 1000 subnet, right? How many RARP server you need to get? In normally company, how many VLANs you have? 20, 30, 40 VLANs. So how many RARP server will require? 40. Because it works on the layer 2, right? But in the DHCP case, what happened? First of all, they will give the all the information regarding the IP addressing. Second thing is what? Doesn't matter how many subnets you have. Doesn't matter how many subnets you have. You will have only one DHCP server. For example, your one DHCP server is present in the Delhi location, right? And you have a sub branches in the Calcutta, Bangalore, Mumbai, Pune, Jaipur. You will get the IP addressing from the Delhi. But in a RARP, it's not possible. So RARP has some issue, right? It's a reverse address regional protocol. They have an issue that it works on the layer 2, and they only giving the IP addressing information. They will not give the any default gateway information. That's IP वो layer 3 पे जा ही नहीं रहा ना, IP का information दे रहा है उसको, पैकेट में IP दे रहा है उसको। मैं यहाँ उसको layer 3 नहीं बना रहा हूँ उसको राउटिंग करने के लिए। वो सर्वर है जो IP का information उसको देगा पीसी को, वहां पे उसको रिस्पॉन्ड नहीं कर रहा है उस पैकेट को, वो बस दे रहा है उसको। एक somebody is requesting, they will give the IP addressing to this guy. He is not routed the packet. Layer 3 का मतलब क्या होता है, तुम राउट कर रहे हो पैकेट को ना, आई एम नॉट राउटिंग द पैकेट। After that, what happened? This RARP protocol was defined in the RFC 903. Simply device such as a diskless function dynamically obtain the suitable IP address. However, because it's acted as a data link layer, it made an implementation of difficult on many server platforms. Also require that a server be present on an individual network. This line. Then after what happened? RARP was superseded by which protocol? In RFC 1980-51, right? In September 1985. The reason was introducing the bootp, right? The reason was introducing the bootp so that they can perform the relay agent. It means that you can have only one server for the multiple domain, which allow the forwarding the bootp packets across the network, allowing one central bootp server to serve host to the many IP subnets. That is not possible in the RARP. Only this issues has resolved in the bootp. RARP has some issue layer 2, right? For RARP, what happened if you have 1000 subnet, you need to look at the 1000 RARP server. So they overcome this problem in the 1985 and they introduced the bootp. So in the bootp, what happened? You will have a one centralized location. And for the one centralized location, what happened? For this centralized location, for the many of the IP subnets, right? And that was amazing on the time 1985. But they only resolved this issue, right? Then after the bootp, what happened? They introduced the and by using the DHCP, what happened? I can provide the extra configuration, right? And the first time the DHCP was used, the reason, I'll tell you one thing, in the 1993, because in 1993, they introduced the concept of classless. So right now, guys, if you remember the RIP protocol version 1, IGRP protocol, all this protocol is it's a classful protocol, right? EIGRP, OSPF version 2, BGP version 4, all these guys are classless protocol. All this protocol has introduced after the 1993 because itself in the 1993, what happened? They introduced the concept of classless. So whatever the like, you are putting the wide extra configuration of the parameter to the IP clients, right? Like a subnet mask information. Remember, right? Any packet that contains the subnet mask information is known as a classless. A packet that does not contain the subnet mask information is known as a classful. Something like this. This is the one packet that have a 1 or 0 or 0 or 0. This is a classful packet, right? And if the one packet we have a 1 or 0 or 0 or 0 or 0 subnet mask, this is the classless. So what DHCP allow you, they can put the extra configuration. And that's why the DHCP was first defined in the RFC 15.1 in the October 1993. Again, they have some issues in this RFC. Then after that, what happened? They make some more small changes, and they will make the new RFC 2131. And then after that, so on. This all this RFC, right? RFC 1531 and RFC 2131. This all for the IPv4. And then after that, they have introduced the basics. So layer 7. Done. So hope this part is clear. What is the meaning of boot over there? Any question about the boot? Why the boot comes in the picture? Why the RARP comes in the picture? And why the DHCP comes in the picture? So how the journey was started? The journey was started like this. RARP, then boot, and then DHCP. RARP was 1984, boot 1985, and DHCP region. So what is the issue with the RARP? Layer 2. And for the for the 1000 servers, we need to have 1000 server. Bootp has resolved this one. What is the issue with the Bootp? They are not giving the complete information to the client. They introduce the DHCP. What is the next line? बताओ क्या होगा? Hardware type Ethernet. Guys, लिखा था ना किसी ने? अबे इधर देख लो, इधर दिखा देता हूँ. मैं नहीं दिया था. Hardware type Ethernet. Your hardware, like your what cable you are going to use for that one, right? Your hardware type can be Ethernet, IEEE NAT, ARCANET, local talk, SMDS, frame relay, SDLC, fiber channel serial line as well as. This guy is just going to tell you what kind of hardware we are going to use. If you have a 0x01, that is just going to represent that this is the Ethernet one. अच्छा, नहीं दिख रहा है क्या? If you're going to use the frame relay in this case, what happened for the frame relay? Your opcode value will be changed with the 50. So hardware type is just going to tell you what kind of technology we are using over there. It's a Ethernet. Next line is what? अबे मैं दे दूंगा ये notepad. मत लिख. I'll give you the notepad. Next line is what? Hardware address length. What this guy is going to represent at? 6 byte. Then after that, we have a hops concept. Here the hops is just going to represent that how many hops my DHCP server is present. Is 0 in the sense one, this guy is my, I'm sending the client is sending the packet, the hop set with the 0, right? If the server is for a different broadcast domain, what happened? Those hops will be incremented by 1. Next point is like, now this is a little interesting concept. Right. First of all, what is the meaning of ID? Identifier. Identifier of the particular things, right? For example, user has an ID card. You have a Facebook account, right? You have an ID card over there. What is the meaning of transaction? Exactly, right? Credit and debit. credit and debit, right? Whenever you're making online transaction, you will have a credit and debit. So whenever you are making online transaction, at the same time, what happened? You will have a one ID, right? They will generate it. Here, the transaction ID in the client and server. In the client and server case, here the transaction ID is just going to represent that a logical session. What this guy is going to reply? A logical session, a logical connection. We can say that made between client and server. If I'm not wrong, this transaction ID size is 32-bit number. Hex format representation. So for every client to the server, they have a separate identifier. For example, this is the router, right? Okay, this is the switchover we have. This is the PC, this is the PC, this is a PC, and another PC, right? So for this guy, we have a separate logical session. For this guy, we have a separate logical session. For this guy, we have a separate logical connection. And for this guy, we have a separate logical connection. A logical session means logical connection, right? One connection that I'm going to make. Session layer, right? Whenever you're making whenever you're trying to book a flight, right? What happened? You are making a payment through the card, and they will create a one session over there, right? And that session is only valid for the 2 minutes, 3 minutes, right? That is a session that I'm talking about. A logical connection that will make a client and router, sorry, server. And each session is going to identify some identifier. This will be a 1, this will be 2, this will be 3, and this will be 4. This identifier is known as a transaction ID. And through this transaction ID, all the packet will be exchanged. So if you just have a look right now, what I can do, delete this guy, and I'm going to put some switch over there, right? Take some router. Then start this guy and capture this thing. Interface 0/0 IP address will be, sorry, not IP address. No, sir, no. Have a look. I have captured this link. And right now, there's 2 clients right now. We have this guy. Let's change the symbol. And I'm going to make this guy the client. Right? And let's do one thing. I say the IP address, DHCP. This guy, and on this guy as well as no scrum. Got the IP? Got the IP? So if you see, this 2 person has a made the logical connection between this guy and this guy, and they both have a separate transaction ID. So if you have a look over there, DHCP, can you see that? Not from here. You can go just from look from here. Mark. So from here to here, this guy's acknowledged, and again this one. Can we see? So all this bit, right? All these 4 packets, we have a same transaction ID. And for all this packet, we have a right. So transaction ID is what? One for the one client, Second, for the another client, transaction ID is what? It's just going to make a one logical connection between the client and server. I'll, I'll, I'll explain. Don't worry about that. I have just gone through the one packet right now. I'm just trying to explain this part. Transaction ID. So this point is clear. What is transaction ID? So this transaction ID will be same. It will be same for all packets for one session. If you're going to make another session, it will be different. For example, if I'm on a client, once the PC will get the IP address, another time what happened on the same PC, I'm going to put the shutdown, no shutdown. What happened? They will make another session ID. Second, elapsed. What this guy is going to represent? How many seconds, right, it took to get the IP address from the devices? Always you will see the 0. Always. Next point is what? The boot flag. What I can do right now, I'm just going to make a next screenshot of this person. This boot flag. Now, what this guy is saying that the boot flag, if I'm not wrong, this is totally a 8 bits. In the 8 bits, what happened? I'm only going to utilize the 1 bit. The rest of the 7 bit will be what? It's a reserved. So this is the reserve flag. These are they are reserved for the future reference. Okay. And even if you go for the RFC, they are not going to define in the RFC as well as. So if the boot flag is 1, right? It means that this guy is a broadcast packet, or it can be unicast as well as. For the unicast, I think so it will make a 0, I think so. If I'm not wrong. We'll see that, don't worry. Let's check it now. I think so. We have released. Yeah, it's a 0. So I'll put this guy. Then depend on the packet set. Right now, the packet is what? The Discord packet. Right now, the Discord packet is what? It's a broadcast packet. Can you see that? The layer 2 is broadcast and layer 3 is also broadcast. So if the packet is broadcast, I need to use which flag? Broadcast. Next information is what? Next information we have a client IP addressing, right? I don't know. Your client IP addressing, this will be also known. Next server IP address, I don't have any server IP address configured. Relay agent, I haven't configured the relay agent. It all set to the 0 in the Discover packet. Because I'm discovering right now, I don't know anything, right? Even I don't know where's server, even though I don't know what's my client IP address, even I don't know the relay agent IP address. Nothing I have configured on myself. Next point is what is relay agent? We have a separate topic on this one. Don't worry. What is the next information we have? The MAC address of the user, right? So if you just go on a router 1 and if you see the MAC address of this person, do show interface fast and 0/0 include BIA, same person, right? Then after that we have a client hardware address padding. So if the like if the requirement is not fulfilled, I need to add some padding bits, right? So I'm not going to add right now. So all set to the 0/0/0/0/0/0. If you're not able to fulfill the packets, right, you have to add some bits over there. That is the meaning of padding. Server host name not given, boot file name not given, nothing is going on. Next one is amazing. This is the call magic of this. That is called जादू. कोई मिल गया का जादू. right? Magic cookies. Guys, this magic cookies is what? Is the extra information about client and server, depend on the packets. So this packet is generated by whom? Client. And this packet is what? Discover packet. So they will put the client information, like what is the host name of the client, what is the MAC address of the client. So if you see in this packet, they are sending the host name information as well as. If you put the host name, it will be CCNA. So CCNA will be sent, right? If you just go on the router and let's set down this guy and say the CCNA name, host name will be CCNA. What happened? Now interface 0/0 no shutdown. See, so host name they are also going to put, and then after that, if you see the client identifier, the client identifier they put the MAC address. Don't worry, guys. On this option field 61, we have a separate lecture on this guy. So we have a 1 hour lecture on this person, right? What is the use of option field over there? Why they are going to put the option fields and everything? Why they are putting the, even if you see they are putting the interface number as well as, right? So magic cookies is what? They will just put the extra information. This DHCP master type is a discover, right? It can be changed according to the types. It can be have a discover. It can be our offer. It can be our request. It can be have a acknowledge. And also this one, release, right? This all information I'm sending in which packet? The first packet that client is going to request to the server. That's a discover packet. All this information. Anyone has a question in this first packet? All clear?
What this number indicates 611257.
Sorry?
These numbers are there, no? 61 12 55.
These are the option field. These are the options number, right? And each option number has a different use. They are just identifier of this field, right? They are just identifier of this way, and each field has a different use, and depend on the configuration, right? Depend on the configuration, your option field will be changed. Also this thing as well as, if I'm not going to configure the default gateway, what happened? Your some option field will be removed. Sorry, some option field will be added. So, sorry, if I'm not going to configure the default gateway, right, your some option field will be removed. If I'm going to configure the default gateway, your some option field will be added over there. The option field is nothing but it's just going to add some extra information about the client and server, and some extra information like this box. So one extra information, another extra information, another extra information, another extra information, another extra information, and each box is going to be identified by the option number. That is a 53, some guys 57, 61, 12, 55, 255, anything. and each option has a different meaning. Clear? First packet is clear. What happened once the PC, right, will send the first packet? What they will do? They will send the next packet. Or in this next packet, what happened? I'll do one thing. I'll make it. The first packet, the Discord packet that I'm sent. Is there any range of option field? Yeah, that's the range is like Nizam. It's a 255 up to you will get it. Type, source IP, destination IP, protocol number, source port, destination port, and DHCP. Copy, paste. Source MAC, destination MAC, type, source IP, destination IP, protocol, source port number, destination port number, and then we have a DHCP. Right? Copy, paste. Source MAC will be what? User MAC address. Take example, I'm going to use the C201. Right? Destination MAC will be what? FFF layer 2. Type will be 0x0 800. Source IP will be 0.0.0. I don't know. Destination IP will be what? Broadcast. Protocol number 17. Source IP, source port number 67. Sorry, 68. Destination DSC packet Discord. Okay. Next packet is what? Source MAC. Now the server will send, right? If the server will send, the server MAC address will be the C202, for example. Destination MAC will be what? Broadcast. In Cisco CLI, all the packets will be broadcast. In Cisco CLI, all the packet will be broadcast. Depend on the platform again, guys. Some packet will unicast, some packet will broadcast. In discover packet, offer packet, request packet, acknowledge packet, all this packet will be broadcast in the Cisco. All the packet. Release packet will be unicast. I'll let you know why the release packet will be unicast. Don't worry about that. Source IP will be what? Server IP. Yeah, I know this thing. Server know the MAC of the source, but again, it's a different on the platform, right? They are doing the different things. If you go for the Linux, they are doing the unicasting. Source IP is what? Server IP. Destination IP will be what? Broadcast protocol number 70. Source port number. Destination port number. Destination DC packets. In this offer packet, what happened? We are going to put the IP information. We are going to put the address. Of course, I'm getting the IP as a dynamic way. So we have some like the times if it is broadcast, every host gonna receive that offer packet, right? Exactly right. But in that case, what happened? The PC that has requested, right? They will have a MAC address as well as over there in the offer packet. So if you see the offer packets, See this part, Nazim. This MAC address is present. So based on that MAC address, they will receive the packet, right? So now if you see, right? This thing is clear. Offer packet. This thing is clear. Type code is 2. In the Discord, it was 1, right? Ethernet is clear. Length is clear. Hops is clear. Transaction ID is clear. This part is clear. This part is also clear. Client IP address. This information, the client IP address, it will see in, right? Okay. If you see, no, this one. In the release packet. Why they are putting in the release packet the client IP address? Because client know what's my IP addressing. Try to understand, if this client will get the IP addressing 1.1 or 1 or 1 or 2, the client has IP addressing, right? But what happens if the client is saying, okay, I don't want any IP addressing? So it will send the release packet, and in the release packet, what happened? They will put the client IP information, right? Client means client. Server IP कहाँ से आएगा? When the client is going to release the IP addressing, huh? So when the client is going to release the own IP address, then in this field, what happened? They will put the client IP address information, right? But right now, what happened? This is the offer packet, right? This packet is the offer packet, right? In this offer packet, what happened? The client IP address will reset to the, because this packet is generated by a home server, and what server is saying that, hey, you can use this IP, your client IP. Client IP address and your client IP address is two different terms are there. Client IP address is only set when client will release own IP. Yeah, by default 000, because that's right now the server is allocating the IP, right? The server is allocating the IP, right? So they will say, okay, you can use this IP address. And after that, what happened? Next server and next release will be what, set to 00, because I don't have this information right now. And after that, the most important information, this part, the client MAC address. In a discover packet, you have seen the client MAC address information, right? So in the offer packet, what happened? He's saying, okay, this client had made a request. I will give this IP to the this client. At the same time, they have a same session ID. Clear this point? Two things is happening. One, I'm going to put the client MAC address so that this packet is only for the that client. Another thing is what? I'm maintaining the session. So this information will be not go to goes by to the another client, right? Next part is what? Again, padding. Host name is not given, boot file is not given, and then after that we have a magic cookies. If you just have a look the cookies information compared to the Discord packet, right? Yep, I know. If you see the disk, not so release packet, go for the Discord one. If you see the Discord packet, in Discord packet we have a this option field, right? In the offer packet, what happened? We have a this option field. The again, I am telling you, the option field is just having a extra information. The DHCP cookies putting a extra information about the client and server. Client will have own information, server will have own information. In the client case, what happened? They are going to put the own client identifier. We can say the MAC address, right? And in the server case, what happened? They are going to put the server identifier. This is my server IP address. Right? At the same time, what happened? After that, I'm going to put the extra information about this because this is the classless, right? I'm going to put the subnet mask information. And now this IP that I'm allocating, right? This IP that I'm allocating for what? As a dynamic way. So if I'm going to allocate this IP as a dynamic way, what happened? I'm going to put some timer over there. It means that this IP is only valid for the this amount of time. The default is what? Release time, renewal time, rebinding time. Three timers out there. By default, when the server is allocating, right? This is the PC, this is the server. This PC will make a request discover packet and the server will give the offer packet. When this guy is giving the offer packet, in this offer packet, what happened? They will put the IP addressing information, right? They'll put the subnet mask information. At the same time, what happened? They will put the timer as well. The default timer is what? 24 hours. It means that this IP is valid for the how many hours? 24 hours. Don't worry, guys. I will explain what is the meaning of release time, renewable time, and rebinding. All this guy has a different meaning. This thing is not given in the book, so just have patience. I will explain you each and everything and what is the use of this thing and why they put the three timers over there. There are some reasons, right? All clear? Any questions? No. After what they will do? Once this PC will send the offer packet, in this offer packet, what happened? Sorry, once the server will send the offer packet to the client, client will receive this offer packet, and what happened after that? The client is saying, okay, I want to take this IP address. I want to take this IP address. So what happened? They are confirming, okay, I need the IP address. Please give me the acknowledge. Try to understand UDP is a unreliable packet. UDP is a unreliable packet, right? They have a source port number, they have a destination port number, they have a padding field, and they have a checksum, right? But what DHCP allowing over there, DHCP is just going to make a reliability to that guy. Same like a IP is what? IP is an unreliable protocol. EHGRP and OSPF is what? It's a reliable protocol because they have a sequencing concept, right? Same thing, DHCP is what? Sorry, UDP is unreliable. DHCP is going to make a reliability. How? By putting the acknowledge. So what happened when this guy saying, okay, it's a request pack. Okay, I want this IP address. What happened? This client server will give the acknowledge. Or in this acknowledge, what happened? Once this person will receive the acknowledge, they will allocate this IP address. So if you see now, the next packet we have request, hey, I need this IP address, whatever the IP address that you have given in the offer. Same information, Ethernet, hardware, hops, transaction ID, boot flag, still broadcast, right? Client IP address don't know. This guy don't know. This guy don't know. Client MAC address, and same option filled. Nothing is different. Only the thing is that if you just compare with the this packet, right? If you just compare with the this Discord packet that is sent by the client, And to this packet, only some option fields are different. Previously, this Discover packet does not have any idea who is my server. Now, this guy knows the client is sending this packet, right? The request packet. The client is making the request packet to the server. Okay, I want which IP address? This IP address. And I'm requesting to whom? Server. For how many seconds? That's you are giving in the least time. 24 hours. After receiving this packet, the server, what server will do? Server will give the acknowledge. Now see the acknowledge. Same information, nothing is different. Same information, yeah. Everything is same, right? Boot flag, IP addressing, next IP addressing client, everything is same. Nothing is different. Once the server, right, will send the acknowledge packet to the client, now the client will allocate the IP. And for all this process, right, can we have a look over there? Not this one. This is the offer packet. And this is my acknowledge packet. Then after that, we have a Discover packet. All this guy, right, from offer discover, all they have a same transaction ID. Every single one has a same transaction ID, same system. Once the PC will get the IP address, now after it, what happened? Take example. Comes with this diagram. Once the PC will get the IP address, what I'm going to do on a PC side, I'm going to say that, okay, shut up. Which packet I'm going to use? I'm going to use the release packet. And this release packet is what? It's a unicast packet. Who is sending? Client to server. Packet is released. The difference is what? I'm sending this. This is my client IP address 105, and I'm sending this IP address to whom? This information I'm sending to the my identifier. Anyone has a questions in normal DORA process? I'm not done. Yeah, this known as a DORA operation. Anyone has questions? I'm done for today. Anyone has a question, you can ask me. I'm telling you, still we have a 8 hours class right in the DSP, so I'm not done. So we will go through the tomorrow again. तुम लोग को नहीं है? नहीं है? ये तो खोज लेना RS में जाके. I don't know why Cisco is doing this thing, right? Even I don't know why they are doing. Because see, as per the technology purpose, they have to do the unicast, right? Because they know the MAC addressing, right? Okay, उसको करना चाहिए था. I don't know.